Hello there, we're going to start this video on the Harrier CBHQ in Mr Chippie's workshop because he's going to do the power supply. And the first thing we've noticed is an unacceptable mains lead with a moulded plug and a nasty join in it. So I'll get onto the customer and just see if they particularly need a lead that's long, in which case we'll put a new one on. There are two core on these, which you might find surprising, but it is a double insulated product, so that is correct. So we're going to take the lid off, and Mr Chippie's job is to do the power supply. Okay, so he's now got the bottom off this. We were looking for anything silly, and there's nothing silly, so straight on with it. And I think he's going to start with the big electrolytic. What's the value?
Alright. 2200, 25 volt.
Is it? Oh, surprise! That is starting to look hot and bothered. Right, we'll leave him with that then, and I'll get a capacitor if we've got them in stock. Right, so we're on to my bench with this Harrier CBHQ. I have 10 minutes so we can make a start. So we're not going to do I'm not going to run it on its power supply at this stage. I could do a pat test, but I want to sort out that stupidly long mains lead. So he's done those capacitors. Let's just move those. And unlike the Harvard, which I can't continue with at the moment because I need an on and off switch, 22mm spacing between centres, double pole switch. Can I spot one? No. Right, same one was used on Marantz stereos, and you know what, there's greedy people out there who want 50 quid for a switch. Right, here goes. We'll plug my standard Cybernet mic in. And we'll run it up on 13.8 volts. Switch picture in picture on. Show it's on the wrong camera. That's the one we want. Switch the radio on. It was last on 19. Change it to 20. And we key up. It's on low power. And it's doing just shy of 3 watts. So we'll give it the benefit of the doubt and we'll say 3 watts. I could say 2.95, but we'll say 3 watts. Manufacturers call 3.5 watts 4 watts, don't they? See what it is on channel 40. 2.9, channel 1, 3. Low power, 80 milliwatts. Check deviation. Wallow. It says it's 2.5 peak, which is exactly where it should be, but we'll check it properly on the other test set behind me in case this one's playing up today. And our current consumption, if we go back to full power, is 984 milliamps. You see, this is part of why we're running these on a separate power supply, not using the internal one. I want to know what the current consumption is, because when I do the transmitter tune-up, I may get 4 watts out of this, but supposing the radio is drawing 2 amps, and it shouldn't be, you know, so I need to be able to see that. So gear's been on a sufficient length of time, so we'll go over to the frequency counter. We'll see what it's doing frequency wise. I've got some blockage in front of the... Is that better? A bit. 2779074. 2779074. I'll do that right away, then it saves having to set the signal generator off frequency, doesn't it? So that wasn't illegally off frequency, but it was probably sufficient to be noticeable. Now then, we'll do the VCO. Channel 40 is done on these. There's no wax in the VCO capacitor, so you can't really tell whether it's being messed with. This doesn't look a messed with set though, unlike the Harvard I was doing yesterday. So our test point earth is still going to be there. Out of interest, I'll see where the chassis is earth in a moment, but I doubt it. So it should be 4 volts. Just bring that down a fraction. Undo me and on transmit. Should be 4 volts. Bring that up a fraction with the red trimmer capacitor. 4 volts on transmit, 4 volts on receive. So out of interest, just to see if that is Earth. Certainly isn't on mobiles, but it is on this. So it looks to me like the chassis is Earth. It isn't. These aren't grounded as we looked on the previous bit of the video on Mr Chippie's bench. It's because it's double insulated. It's a shrouded mains transformer which is double insulated because it has a primary and a secondary. So that's their take on it. Right. I'll tell you what. We'll do the transmitter. So back to channel 20, see if we can get a bit more power. So we've done these loads and loads of times on this channel, so it's all about getting 4.4 watts out of it, balancing it and then dropping it to 4. It'd be even better if I knew where my blue tool is. It's there. So here we go. So we've got a peak now at 3 watts. I'm going to have to change scales. As the transmitter heats up, of course, it's dropping. We're still at 3 watts. So these 3 for maximum temporarily. So we've just got 5 there. Sorry, we've just got 4, I'm telling you lies. That is at peak. 4 and a fraction. 4.2. I'll just go back one coil just in case it's changed. It hasn't. So this, we've got a situation where the radio will not do 4.4 watts. So in order to balance it, we're going to have to take the yellow one clockwise so that the power just starts to move down. So there we are at 4.4, 4.2-ish. And then the green one anti-clockwise, so that one clockwise is supposed to be for 4.4, but we can't achieve 4.4, so we don't do 4.2. And then the green one anti-clockwise, the manual says for 3.8 watts. Remember, they've got to get them through customs, but we're going to give what you're allowed, which is a full 4 watts. And remember, 4 watts on my test set will be 7 watts on a hobby meter. There we go. We are at 4 watts. Now, I want it to be within 0.1 between channel 1 and channel 40. So on channel 40, it's 4 watts. And channel 1 is 4 watts. Well done, Mr Tango, got one right. Wow, I'm pleased about that. Now the current consumption is 1.16. Low power. Low power, when I find the switch. Sometimes these are dirty, sometimes they're broken. Well, I wouldn't think it got used much on a base station, so you never know. .400 milliwatts. Exactly where it should be. And then I'll do the transmit meter. I can't really tilt the setup. I'll kind of adjust it and then show you. There we go, if you can see that. Meter lamp is lit, even if you can't see it. Does this version have public address? No. So I've got to spend hours rewiring the public address switch on that H407 Harvard, and this hasn't got one. Right, I'll plug the extension speaker in, but it's not the extension speaker, it is the test instruments. Well, that's good news, I can hear it at 0.3 of a microvolt. Check that RF gain's at full, it is now. Check that delta tune's in the central position, it is now. So, let's have a look at what we've got. Go to the SINAD meter, turn the volume up to something meaningful. Well, I'll tell you what, this is already pretty hot. 0.45. For 10 dB, 0.42. Just coming in at 1 microvolt. Squelch to full, and then adjust the attenuator 1, 3, 10, 30, 100. It's coming in 100. That's exactly where we want it to be. Our threshold, we'll turn the signal generator to standby, then we'll park it at 0.3 of a microvolt, turn the squelch down on the radio, set threshold, signal generator back on, 0.48. Right, we'll go through the receiver and then I'll have to go and do something else. All these little 10 minutes here add up. This is the advantage of not having a television in the house, because a lot of people have got 10 minutes on their hands, might sit down and watch the telly and waste that 10 minutes. But there you go, we get through these bit by bit like that. Right, we'll go over to the oscilloscope. There's 100 microvolts on. Do the detector. Wow, that's miles out. That needed doing. Bet that was garbled. Off frequency and detector out. Bet it was a right garbled racket. Right, here we go. You get the extra coil in the base station, and you get the other extra one. I think it's that one. So you get the extra one. So we'll just get that to about 4 dB, so we're not saturating the receiver. See if we can get any improvement. Just put it over the SINAD meter so you can actually see what I'm talking about. Well, look at that. Drop the signal generator back to 4 dB. They're spot on. A bit more now for the IF. And the one under there. IF's miles out on this set. That one's right there. We'll have to do the detector again. Just in case. I'm going to go through the whole thing again with it being that far out. I'm going to take a pause at this point, even though I've not finished that. Okay, so I'm back with you. We've got 0.28 for 12 dBs. 0.25 for 10 dBs. 0.77. That, I had to go through that 3 times because a lot of it's interactive. Squelch. No, I think I'll do the S meter next. So I can't really show you this. It's currently reading 7. So it's 300 microvolts for S9. So we'll just improve that to 100 microvolts where it should be. See if we can show you at the same time. There we are on S9. That leaves us with the squelch, which was spot on as it was, but it may not be now. So we'll turn the squelch to full on the radio, and we'll go over to the attenuator on the test set. 1, 3, 10, 30, 100. It's still 100. And the sensitivity now, minimum squelch, park it at 0.3, set the squelch on the radio to threshold. And it's 0.56. I can't even read my own thing, it's 0.53. So that's basically it. Now I've got to go out. So I've got to call out. So I'll be back when I'm back. Right, so it's the next day. Yesterday, off camera, I did just do the deviation. It turned out to be 2.6, and just that tiny fraction too much. So it's now averaging 2.2 with a 2.5 peak. So it was 2.6. So we've done all the technical side of it. So really, it's just putting it together, back testing, that kind of thing. Just clean up where Mr Chippie's worked there. And then when the isopropyl alcohol was dried in 10 minutes, all we need to do is to align the power supply. Right folks, well we're on the mains now. I ought to have pat tested it first, but I didn't. So let's see where the output is. Is it that one? Could be. That's running low, isn't it? It looks to be running at 12.15. So we set this at 13.8 volts. I haven't got the other cameras on, so I'll have to just go into transmit and tell you what it says. It's 3.5 watts. So that figures. Let's go for 13.2. Not easy to get to on this. That's going down. Let's try it there. It's doing 4 watts. Good, that's another job done. Right, where's the pat tester? Matter of screwing it together. So this one is double insulated. Right, so now we'll just go through that again. I'd forgotten to switch it on, hadn't I? It should be in camera. Okay. Right, we'll get that put back together. And Bob's your uncle, as they say. Right, so we've got the lid back on. But I haven't screwed it on because I discovered this corner, the vinyl veneers coming away. So I've just used Bostik impact adhesive there and I've put scotch tape on. We'll leave that for 24 hours. And for me to get the scotch tape off properly, we're going to need to take the lid back off. So we'll leave it as it is at the moment. So let's see if we can slant it upwards a bit. We'll use it with our mic for now, and then during the on-the-air test at the end we'll go over to the customer's mic, which I think is a replacement. Alright, we'll try again. I'll just prop something under there so we're not creasing the aerial connector. Yes, it is, isn't it? 1 Anna, Roger. So it's Saturday, 1 o'clock. Check our gains up. $19, Roger. I think the RX light's out. I think it is. I'll look into that. But other than that, we're done. So we'll be doing an on-the-air test later on, and it's nice to see another Harrier CBHQ back in the land of the living. Notice how off frequency he is. This is the problem, isn't it, with all those people operating on illegal radios. So they don't do all the digits, do they? So there we go. Thanks for watching. On the air test later, Harrier CBHQ from 1981 using the Cybernet 134 channel.